Section 4.4, Logarithmic Equations and Functions. Part 1, Finding the domain of a logarithmic function. Remember that the logarithmic functions are inverses of exponential functions, and the range of an exponential function is all positive real numbers. So that means the domain of a logarithmic function is all positive real numbers. So if I'm asked to find the domain of f of x equals the natural log of 3x minus 15, I know that I can only take the log of positive numbers. So whatever I'm taking the log of, which we call the argument of the log function, has to be positive or greater than 0. So to find the domain of a logarithmic function, set the argument of the function greater than 0 and solve. So here I add 15 to both sides and get 3x greater than 15. Divide both sides by 3, and I get x is greater than 5. In interval notation, that would be 5 to infinity. For g of x, I have g of x equals the natural log of 15 minus 3x. So again, whatever we're taking the log of, so the argument of the log function has to be greater than 0. Here, if I subtract 15 from both sides, I get negative 3x is greater than negative 15. Divide by negative 3. And I get x is less than 5. Remember, when you divide both sides by a negative, you need to switch the direction of the inequality. So for this one, the domain is all real numbers less than 5, so negative infinity to 5. Let's try this one. Find the domain of h of x equals log of x minus 4 over x squared plus 4x plus 4. So the argument of this function is x minus 4 over x squared plus 4x plus 4. And we need that greater than 0. Now in chapter 3, we talked about how to solve rational inequalities. So I'm going to follow those same steps we did then. I will first factor everything, so that denominator is x plus 2 squared. And then find all the zeros of both the numerator and denominator and put those on the number line. So the 0 of the numerator is 4. The 0 of the denominator here is negative 2. And then I need to pick a number in each interval, so less than negative 2, between negative 2 and 4, and greater than 4, and decide if the graph will be positive or negative there. So if I pick a number greater than 4, let's say 5. If I plug in 5, I get 5 minus 4 over 5 plus 2 squared. That would be positive divided by positive, so that would be positive over here. Between negative 2 and 4 is 0. If I plug in 0, I get negative 4 over 2 squared. That's negative. And if I plug in, say, negative 3, less than negative 2, I would get negative 3 minus 4 over negative 3 plus 2 squared. The denominator is always non-negative because it's squared, and the numerator would be negative. So it's negative over here. And we want where it's positive, so 4 to infinity would be where this function is positive.